So now let us discuss the second point of subtraction of vectors, okay, which is exactly like addition. How is it like addition? So subtraction of vectors, how do we do it? So when I say A minus B, this is equivalent to saying A plus minus B. Okay, so what I need to do, I need to reverse the direction of B, keeping the same magnitude, and then add it with A. So how do I do it? Let's say if I have a vector A and I have, let's say, a vector B like earlier. So I need to find out A minus B. Okay, so what will I do? I will just reverse B. So this was plus B, so this is minus B because I have reversed the direction. Okay, and then I need to add this minus B with A. So how do I add? So I need to have a continuous there should be continuity between the two vectors. So I transpose this minus B here, so this and this, so there is a continuity now. So then I join this point with this, so this gives me A minus B. Okay, remember what was A plus B? A plus B was somewhere like this, so this was B, so this gave me A plus B. So A plus B is this and A minus B is this, and then all other rules of calculation of the magnitude and direction is the same as the addition of vectors. Okay, so this was quite simple. So then we discuss multiplication of a vector by a number. So if, let's say, a vector A is multiplied by a number n, so the magnitude increases by that factor. Okay, so if A has a magnitude of 5, let's say mod of A is 5 and n is equal to 2, so then NA simply means that the mod of NA is equal to 10. So now let us move on to another very important topic of vectors, that is resolution of vectors. Okay, what does this mean? So let's say if I have an axis, okay, so I have x-axis here and I have y-axis here, and I have a vector. Okay, let's say this is a two-dimensional vector, okay, only on the xy plane, and this makes an angle alpha with the x-axis and an angle beta with the y-axis. So let's say this is OA. So I can actually resolve this vector along the axis. This is very important principle in physics and it is used a lot. Okay, so let's say I drop a perpendicular from point A to both the axes. Okay, so I call this, let's say, x1 and I call this y1. Okay, so OX1 is the projection of OA on the x-axis. Okay, and what is the value of OX1? Value of OX1 is A, so I denote the mod of A by A, so A cos alpha. And what is the value of OY1? A cos beta. Okay, so I can write this vector OA as, what can I write this vector OA as? OX1 plus OY1, sum of these two vectors. Okay, and actually on the x-axis we call I as a unit vector. Okay, unit vector is a vector which has a magnitude of 1 and direction along the x-axis, and J is a unit vector with magnitude 1 and direction along the y-axis. So I can say OX1 to be A cos alpha I plus A cos beta J, which is quite simple because I is direction. So I is giving the direction, A cos alpha gives me the magnitude. So this is along the x and this is the component along y. So A can be resolved like this. Okay, and if there are let's say the vector is a three-dimensional vector. So let's say we have z-axis also. Let's say this is the z-axis, okay, and the vector is a three-dimensional vector, and let's say with the z-axis the angle is gamma. So we can say A is equal to A cos alpha I plus A cos beta j plus A cos of gamma k. So k vector lies in the direction of z-axis. Okay, so it is very simple to resolve any vector in these three axes, and it is very important to be able to do that. Okay, so this means that any vector, let's say I have any vector, and I have any line and a perpendicular to that. So if this is my axis, let's say this is my x, this is my y, and I know the angle, let's say theta, so I can say that A along x, so A along x means the component of A along x is equal to A cos theta, and component of A along y is equal to A sin theta. So of course these are the modes.